Okay, in the name of God, and hello to all the students. Mr. Muhammad and Mrs. Leila, do you have my voice? Okay. Mrs. Leila Zair, do you have my voice? Okay. In this chapter, we will talk about semi-topological group and topological groups. Okay? After this, let me say that I hope that your prayer is acceptable, or okay. دعواتكم مقبول إن شاء الله. The content of this session. In the previous session, we see the definition of groups, and also we see the definition of topological spaces. Okay? Now we have two another definitions. We call a triple G2 star a semi-topological group when G with 2 is a topological space and G with this star is a group. So that this star is a binary operation on G and 2 is a topology on subset of G. And the group operation star from G times G to G that maps X and Y to X star Y is continuous in each variable separately. Okay? When there is no ambiguity as to what the operation and topology, we will simply use G and we say that G is a semi-topological group if we specify these two and this binary operation. Okay, so we have this definition for semi-topological group. Let G and A star be a group and G and 2 be a topological space. Then the triple G2 star is called a semi-topological group wherever the operation star from G times G to G is separately separately, and this is the definition of separately continuous function. A star is separately continuous if and only if for any x0 in G, this function is continuous. G x0 by this function rules. G x0 of y equal to x star y. So that this is a function from G to G because we fix this x0. Also y0, this function gy0 from G to G is continuous. gy0 of x equal to x star y0. These two functions must be continuous. Okay. Dear students, do you have my voice? Let G and a star be a group. Okay. Then a star from G times G, or we can write a star is a function from G times G to G. Okay. A star is a function from G times G to G. Now, for each x0 and y0 in G, we can define two below functions. Gx0 from G to G by this function rules. Gx0 of y, for example, equal to x star y. We know that x star y is an element of G because this function maps, for example, x and y to x star y. Okay. And another function gy0 from G to G by this function rules. gy0 of x equal to x star y0. This x is an element of G and this y is an element of G2. so that from this function we have these two functions. Okay, now if we have a topology on G, then we can talk about continuity of this function, and this function. Okay, now if we consider a topology such as tau on G, then we say that G is semi-topological group, is a semi-topological group, or more completely, G star 2 is a semi-topological group. Okay, well, for any x0 and y0 in G, Gx0 from G to G. Okay, and Gy0 again from G to G are continuous. Okay, for any x0 and y0, these two functions are continuous. Then we say that this G is a semi-topological group. Okay, we say that G is a semi-topological group whenever for any x0 and y0 these two functions are continuous. Let me read this definition again for you. Let G and A star be a group, and G and tau be a topological space, or let tau be a topology on G. Okay, then the triple G tau star, or simply G, is called a semi-topological group whenever the operation A star is separately continuous, or equivalently for any x0 and y0 these two functions are continuous. These two functions are continuous. And also we have this definition for G to be a topological group, not semi-topological. Topological group, we require G to satisfy all of the conditions for a semi-topological group, as well as two more requirements. The group operation star need to be continuous, in both variable, not separately, jointly continuous together, and the inverse mapping given by x map to x inverse need to be continuous. So that we have this definition. Let G and A star be a group and G and 2 be a topological space. Then the triple G2 star, or simply G, is called a topological group whenever we have these two properties. One, the binary operation star from G times G to G is jointly continuous. This function be continuous because this is a topological space and this is a topological space. If this function is continuous, we say that this is jointly continuous. And two, the inverse map is continuous. Inverse map is a function from G to G, but this star is the function from G times G to G. Okay, if this function and this function are continuous, we say that G is a topological group. So we have two definitions: semi-topological group and topological group. If a star is separately continuous, we say that G is semi-topological group. And if a star is jointly continuous and the inverse map is continuous too, we say that G is a topological group. Dear Muhammad, it is clear or not? Wa alaikum assalam Qassam. Now we have this proposition. The function gx0 from G to G is continuous at y, for example. We know that this is the function from G to G, okay? And we know the function rule of this function. Gx0 have this function rules for any y, gx0 of y equal to x0 star y. Note this function is continuous at y if and only if for any v in our topology such that contain this element, there exists another element in our topology such as u, such that this u contains y and x star u is a subset of v. We know that x star v x star v equal to x0 star u equal to the set of all x0 star x, for example, such that x belong to u. In our book, denoted this set simply by this notation, okay? This equal to this, and this is the definition of this left cursor. Okay, please read the proof of this proposition from the book and from this booklet. Let me write some sentences for you. Okay, سأرسل لك الملفات. Okay, I send for you the file of this board. Here is the proof of these two propositions from the book. يرجي قراءة إثبات الاقتراحين الأخيرين من الكتاب أبريل كتيب. Okay, dear students, it okay, and also please note that to this sentences نقوم بتحميل بعض الملفات غير المتصلة بتدريس هذا الدورة for you. Okay, يرجي مراجعتها. أقوم بتحميل هذا الملفات إلى النظام in OU. Okay, I upload these files or these sessions in OU system. Please read this offline files in OU systems. Okay, so we have these two useful propositions. This function is continuous at y if and only for any neighborhood of x star y. This is the neighborhood of this element, okay? There exists a neighborhood of y because this is open and contains y. This is a neighborhood of y such that we have this inclusion. And two, the functions gy0 from g to g is continuous at x, for example, if and only if we have this implication for any v into such that x star y0 belong to v, there exists a u into such that x belong to u, and we have this inclusion. Okay. I use for the proving of this proposition another proposition that I denoted by a star, okay? This is a very nice proposition. Let's read this proposition. This is very useful for you, okay? This is very useful for you. And this is a star proposition, okay? All of these statements equivalent to the continuity of the function f. If x and 2x and y and 2y be topological space, and bx be a base for 2x and by be a base for 2y, and f from x to y be a function, then f from x to y is continuous at x0 equivalent to this statement, and this is equivalent to this statement. This is very, very important. I denoted this proposition by a star, okay? And you can follow the proof of this important proposition from this booklet. Now, in the proof of this proposition, we use this proposition, okay? And you can prove this easily by the proposition star. And in this remark, we say that a statement y equivalent to the statement 3 and the statement 2 is equal to a statement 4. I write this for you. 1 equal to 3 and 2 equal to 4. and this is 3 and 4 for any v in this. I recall that this is the set of all neighborhoods of this element x0 star y. Neighborhoods of this element. If v be a neighborhood of this element, there exists a neighborhood of y such as u, such that we have this inclusion. And to equal to this statement, for any neighborhood of x star y0, there exists a neighborhood of x such as u, such that u star y0 is a subset of u. So sorry, is a subset of v. This is v, okay? Let me write this better. This is v. Okay. Sorry dear students, let me a minute. سلام های دکتر. ارادتمند، حال شما خوبه؟ خوبه انشاءالله. کلاس بودم دکتر، یه شما برداشتم. قربان شما. خواهش بود. بله دکتر، من فردا تو بحث اداره مالی سوال میکنم، خدمتتون تماس میگیرم. انشاءالله مشکلی نیست. چه روزی تشریف میاد آقای دکتر؟ چشم دکتر، میپرسم خدمتتون خبر میدم. بد نیست دکتر، بد نیست. در خدمتم دکتر. قربان شما، خدا. I'm very sorry dear students. And these two equivalence prove easily. For example, if we consider a statement 2, this is a statement 2, the function g by 0 is continuous. Okay, then we have this assumption. There is this condition, and we know that, for example, a function t. Let me write this for you. T from x to y, okay, is continuous if and only if and only if for any open subset such as V, okay, such as V, for any V as an open subset of Y open. The inverse image of V is an open subset of X, okay? And this is equal to, if V be an open subset of Y, then its inverse image is an open subset of X, okay? Now we have this function in a set of t, okay, and x and y equal to t, so that this function is continuous, and this is continuity at x. Let me write this definition again. T from x to y is continuous at x0 if and only if and only if V be a neighborhood of T of x0, then its inverse image is a neighborhood of x0. Its inverse image is a neighborhood of x0. We use this definition, okay, and you can find this definition in your books. Let me find this for you. Okay. This is definition of topology, and this is the definition of continuity at one point. Let x and 2x, y and 2y be topological spaces, and f from x to y be a function. We call a function, if the function f is continuous at x0, if the following holds for any neighborhood of f of x0 or t of x0. The inverse image of this neighborhood be a neighborhood of x0. And you know that this is the definition of neighborhood. A set N is a neighborhood of X if there exists some open set with X belonging to U and U be a subset of N. In other words, N is a set that contains an open set containing X. So that neighborhood of X are subsets such that contains an open set containing X, and the set of all neighborhoods of an element X will be denoted by an X. Okay. Now, since this function is continuous at X, we have this implication for any neighborhood of Tx, for example, Fx. This is our function g by 0. The inverse image of this neighborhood must be a neighborhood of X. So, we have this statement, this equal to this for any neighborhood of X star y 0. This must belong to Nx. This is very easy because this inverse image equal to this set. I write this equality for you. If X belongs to this inverse image, this is equivalent to g by 0 of X belonging to V. You know that X belonging to the inverse of V, for example, if and only if T of X belongs to V. Okay, T of X belongs to V, and this is equal to X star y 0 by the function rule of g by 0, so that this equal to that this belong to V, and this is equivalent to this X belong to V star y 0 inverse. It is very trivial because X star y 0 X star y 0 or X0 is X star y 0 star y 0 belonging to V equal to there exists an element in V such that X star y 0 equal to V, and this is equal to there exists V in V such that X equal to V star y 0 inverse, because we now act the inverse of y 0 in both sides of this equality. Okay, and this is equal to X belong to V star y 0 inverse. Okay, because this is an element of V star this. Okay, and you know that this equal to this g by 0 x equal to, so that this statement equal to this statement, so that for any neighborhood of X star y 0 this must be a neighborhood, so that there exists an open set such as U, such that X belongs to U and U be a subset of this. This is the definition of neighborhood, that we recall at the moment, okay? So that we see that 2 and 4 are equivalent, okay? Okay, and also we have this proposition Walaikum Assalam. Welcome all students. Dear students, do you have my voice? We have this proposition 2. Psi, for example, from G times G to G by this function rule is jointly continuous. This psi is S star itself, okay? This is S star. S star for example, from G times G to G by this function rules, X and Y maps to X star Y. I denoted this by S star, okay? Psi of X and Y equal to X star Y. These two are the same, okay? This function is continuous or jointly continuous if and only if for any x and y in X and for any neighborhood of X star Y there exists two neighborhoods, a neighborhood of X and a neighborhood of Y, such that U star Y is a subset of W. And the proof of this is easy, because this function is continuous at this point. For example, if and only for a neighbor of X and function t equal to psi, okay? This t equal to psi, this x equal to g times g, and y equal to g, okay? For any neighborhood of tx0, this tx0 equal to psi of x and y, okay? Consider x equal to g times g, y equal to g, x0, x and y, t equal to psi, equal to psi. Now use the definition of continuity at x0 or x and y. This function is continuous if and only for any neighborhood of t of x0, psi of x and y. The inverse image of this is a neighborhood of x0, x and y, or point. Okay. And this holds if and only if for any neighborhood of x star y, because this equal to x star y. Okay, this is our function rules. Psi of x and y equal to x star y. This must be a neighborhood of x and y, so that there exists an open set such that x and y belong to this open set, and w prime, for example, is a subset of the inverse image of w. Okay, this is the definition of neighborhood, because this must be a neighborhood of point, so that there exists an open set such as w prime, such that this element belong to this open set, and this open set be a subset of this neighborhood. And this holds if and only if for any w at a neighborhood of x star y, there exists an open set in product topology such that contain x and y, and w prime is a subset of this statement repeated. Okay, and this holds if and only for any neighborhood there exists a neighborhood of x and a neighborhood of y such that u times v be a subset of this, not w. This is a star, and we can see that the proof of a star is whole because this beta is a base for product topology, so that since this is an open set, okay, since this is an open set, there exists a member of its base beta. There exists a member of this beta such as u times v, such that x and y belong to u times v, and this is a subset of u prime. So we can write instead of this statement, and this holds if and only if there exists u and v with these properties, x belong to u, y belong to v, such that u star v is a subset of w. We write instead of this statement, and this is a star because u times v is a subset of this inverse image if and only if psi of this set is a subset of w. We take psi from both sides of this inclusion. Okay, psi of this is a subset of psi of this, and this is equal to, it is equal to this be a subset of w, but psi of u times v equal to u star v, and we have this proposition 2. Please note that w is the neighborhood of x star y, then there exists two open sets such as U and V, such that each belong to U, Y belong to V, and U star V be a subset of V. This is equal to, for any neighborhood of X star Y, there exists a neighborhood of X and there exists a neighborhood of Y with this property. This is very, very nice equivalence that I write the proof of this for you. 1 implies 2, 2 implies 1. Okay. Let me take some example. Any group with the discrete topology is both a topological group and a semi-topological group. Because if we consider discrete topology, we know that any function is continuous. Any function is continuous. If we consider discrete topology, we know that any functions from G to G is continuous. Okay, so that if we see the definition of semi-topological group or topological group, it is very trivial that these functions are continuous. If we consider the topology of G, discrete topology, this function is continuous, and also these functions are continuous because this is discrete space, and any functions by the domain of discrete topology is continuous. Please note that. Please note that if X is a discrete topology, and Y is an arbitrary topological space if X, let me write X have discrete topology or consider with discrete topology, and Y is an arbitrary topological space, then any function t, for example, from X to Y is continuous, because for any U, because for any open subset of Y, open, okay, the inverse image of V is a subset of X, so that this is open. We know that in discrete topology, any subset of X is open. Discrete topology equal to whole of P of X. So that this is as a subset of X must be open. So that the inverse image of any open set is open. So that any function is continuous, okay? Any function is continuous. And so, if we consider discrete topology, any group is topological group and semi-topological group. For example, S3 and P of S3. This is discrete topology of S3. Sorry. With composition is both a semi-topological group and topological group. And also we have this nice proposition. Let me prove this for you in the next session. Dear students, do you have any questions? Operator class not hold, okay? Let me write this for you. لم يتم النظرية فئة المشغلين غدا. Tomorrow the operator theory class is not hold. Okay, do you understand, mom? Okay, but please note that okay. لكن الدروس تقام يوم الثلاثاء. سنبدأ الدراسة يوم الثلاثاء الساعة 3:30. Okay? Okay. Thank you very much and thank you for your attention. Goodbye for now.